Fashion Tech Alliance involves higher educational institutions, small, medium, and big enterprises, and the research center. This project has been co-founded by the Erasmus Plus program of the European Union and is aimed to facilitate knowledge exchange between partners and to design and pilot learning experiences to engage students in a fashion tech residency program, embedding young talents in the company's innovation activities. A central objective of the project is to design multidisciplinary, interdisciplinary, and intersectoral learning activities involving international students from 5 European universities. The contents of the lectures have been specifically created to match the needs of fashion tech learning. They have become open educational resources to allow future engagement between a European-wide fashion and textile HEI community, and are available under Creative Commons Sharealike 4.0 with the aim of a wide and free distribution, access, use, and reuse. Ready to learn more about fashion tech? Enjoy the lecture.
Hello and welcome everyone to today's lecture on sustainability in smart textiles. My name is Youngjin Chae from Sustainable Design Engineering Department at Delft University of Technology. This page shows a table of today's 30 minutes lecture. Followed by the introduction, 3 different definitions of sustainability will be shared. Then, definition, opportunity, and challenges in smart textiles will be introduced prior to demonstrating possible approaches to sustainability in smart textile products. Introduction. Here, an overview of sustainability in advanced technology will be given to define the current challenges in smart textile products. 4-dimensional approach of material, design, energy, and additional value would be introduced to overcome the limitation of sustainability in smart textile products and wearable systems. Let us start from the basic definition. What is sustainability? We frequently hear the term sustainability in many different aspects of life. Sustainability has been first defined as meeting our own needs without compromising the ability of future generations to meet their own needs in 1987 at United Nations Brundtland Commission. Sustainability is also known as a complex and multi-dimensional phenomenon that combines long-term implications and non-linear behavior that cannot be solved by the mere application of technological or scientific methods. Therefore, discussions of sustainability in advanced technology is a challenging matter, because it should consider the risk of the new and novel technologies under conditions of uncertainty, which is the future, and without the quantitative evidence. Today in this lecture, we will be specifically covering the topic of smart textiles as a type of emerging and advanced technology. Smart textiles is a widely selected medium of these wearable devices that is defined as an intelligent textile structure or fabrics that sense and react to various stimuli of the user and the surrounding environment. Let us share one video.
The weather downtown is currently 65 degrees. Today at 10 a.m. you have a dance audition. Traffic is heavier than usual. It will take you 23 minutes to arrive at your destination.
Yeah, okay. 1 minute, Ella. No, not you. Uh,
The video that we have just shared shows a recent trend of wearables and smart textiles and smart clothing in a consumer product of Google Jacquard by Levi's. This shows a smart clothing system based on smart textile technology that is considered as the next generation of wearables. The current ridge and small wearables with limited interface is shifting to a large and flexible smart clothing system with unlimited interface by seamlessly integrating and connecting the physical and the digital function through smart textiles. Worn on the body area for an extended period of time, smart clothing is known to significantly enhance the user capabilities and comfort that is connected to a wider range of users' lifestyle. As clothing being one of the most common life and user-friendly artifact in human history, and with the producing power of 150 times larger than that of smartphones, smart clothing already represents the largest potential distribution network of wearables. The market is already growing, and its growth rate over 33% compared to that of 2017. Smart clothing market is predicted to reach 9 billion by 2024. However, as smart textile wearables lies between the three different disciplines of software, electronics, and textiles, the user engagement, life cycle, and disposal patterns shows a complex matter that cannot be simply determined by single technology or market characteristic, such as that of clothing or electrical product range. Therefore, it gets even more challenging when it comes to define the context of sustainability in smart textile products. One main challenges are that the market and the disposal behavior of textile and electronic products, which are considered as the essentials of the most of us living in 2020s. Textiles and clothing are a fundamental part of everyday life and an important sector in the global economy, and it is hard to imagine a world without textiles and clothes. Clothing and textile production that has approximately doubled in the last 15 years is now leading to a massive number of non-renewable waste after being used for only a short period of time. More than half of clothing is known to be disposed within a year, with textile materials largely being lost to landfill or incineration. Disposal has also dramatically increased, where 73% of their materials end up being in landfill, while less than 1% of the material used to produce clothing is being recycled to a new clothing. This represents a loss of more than 100 billion euros worth of materials each year. Electronic products have similar issues on waste matters that has been steadily increasing every year due to their shorter fashion cycles, and increased production. Electronic waste is defined simply as items of all types of electronic equipment and their parts that have been discarded by the owner as waste without the intention of reuse. And their effect on human health and environment are very complicated to predict. Today, the lifespan of many devices are discarded and replaced by newer version and improved technology, leading to a shorter life cycle that is also coupled with the increased production, consumption, and waste. Electronic appliances and devices that are still available to use and still has a value in it are easily being discarded as waste and ultimately ending up in landfills. In the US alone, for example, 70% of heavy metals found in landfills come from this discarded electronics. Every year, a size of Manhattan is being covered with e-waste when it's jammed side by side. Amount of disposal expected to double until 2050 compared to that of 2021. Other challenge than the market and the disposal behavior can be also related to the structural integration of functional components within the textile geometry. The conductive material that is commonly dispersed with large amounts onto the textile geometry not only make it difficult when recycling these smart textile waste, but also makes it even more challenging as the electronic components can act as a contaminant in the recycling procedure. In this slide shows an example of conductive structures inside the smart textile materials, which the functional elements being into a large volume of textiles, where the conductive materials are colored in red, while the non-conductive materials are in gray. And you can easily find the integration, or maybe to putting these two parts apart can be challenging for most of the cases. Challenge are also related to the limited resource and materials that is frequently used for smart textile product development during their functional integration. Innovative products, including smart textiles, are highly dependent on a range of critical materials that are frequently diluted within waste streams without being secured or reused. Therefore, recently, awareness to these critical materials for sustainable product development are being raised. Let us take batteries as an example. Lithium-ion battery is a commonly selected type of power source for portable electronics and wearable systems. It is critical to have sufficient power to run a smart and portable device for an extended hours of day. However, although batteries are recyclable, less than 5% are being recycled due to technical, economic, and other factors. Industry analysis predict that the amount of the usage of lithium-ion batteries will hit 2 million metric tons per year worldwide by 2030. This means two common cathode metals of cobalt and nickel, which are the most expensive and precious components that have fluctuated sustainability in recent years, are being disposed. What has been and what can be done would be discussed in this part. To improve the sustainability matters in precious resource, approaches have been made by following suggestions addressed by European Commission 2010. Two of the most relevant suggestions related to today's topic can be encourage lifecycle assessments for raw materials and their products in a cradle-to-grave basis, and to minimize the raw material use to obtain a specific product function. Specifically in smart textile materials, efforts are also being made to minimize the use of expensive materials such as silver by replacing it to a less critical one. Also, advanced technology is also trying to support the less use of the materials, such as by introducing the technology of nanowire coating methods that use 95% less conductive materials compared to that when it's being applied by a solid film type. This not only decreases the total amount of the critical materials that is being used for the production, but also lowering the cost of the final product. Next approach is related to the circular economy. Circular economy is one of the adaptable approaches where a new vision in textiles and electronic products can be made for a sustainable solution by minimizing its negative impacts by keeping their highest value to the product during use and after use without ending up in a waste. A circular economy is a systematic approach to economic development designed to benefit business, society, and the environment. Contrast to the take, make, waste linear model, circular economy is regenerative model by design. Another solution for sustainability in smart textiles has been discussed through different levels of design strategy. Design strategy for sustainability has been first claimed to fulfill users' demands in less material and energy intensive ways in 2007. Also, the means of emotionally durable design has been suggested to reduce the loss of critical elements in difficult to recycle waste streams for longer lasting products. Most recently, implementing design for recycling and value creation during the product development has also been suggested to keep critical materials longer in the circular cycle chain by Andreas in 2013. What we can build upon these challenges and the recent approaches will be shared in this part of the presentation. Recently, modular system has been introduced in smart textiles by subdividing the whole system into a smaller parts. This makes it easier for the whole system or the new system to be modified, replaced, or exchanged with other modules, leading to the improved performance, lifetime, and usability in the overall system. This modular approach is suggested as a new functional system for sustainability. Smart components of the modular system, such as sensor, actuator, battery system, would be able to be easily separated to be updated, replaced for different and selective applications without discarding the entire system. Conscious design that considers life cycle perspective and implementation of eco-design can be another approach to achieve sustainability in smart textile products. Through conscious design methods, life cycle assessment for a wearable smart textile device has been suggested through the material selection and the prototyping stage in 2015. Design techniques and tools for conscious design has been also demonstrated by reclaiming and reusing smart textile materials in 2020 through human-computer interaction researchers. By unveiling a garment into yarn, approaches were focused to design smart textile products for disassembly by implementing the existing properties of knitted and woven textile products. Energy harvesting technology that collects various forms of energy from the surrounding environment is considered as one of the solutions for sustainable smart textile product development. Recently, approaches have been made to develop self-powered smart textile products by using energy harvesting technology. Solar energy, triboelectric, and piezoelectric generators that respectively harvest energy from the sun, friction, and physical mechanism are the most promising ways to collect energy as an ideal power source for wearables and smart clothing systems. Finally, adding extra value should be addressed in smart textiles in the context of sustainability and circular economy. New guidelines to create additional value by making wearers more aware about sustainability can be one of the approach. By suggesting higher social levels of engagement of smart clothing system can be suggested, which is comparable to the current user-centric concept of wearables. Particularly, approaches has been made by introducing material circularity index that correlates the loss of material circularity of a quantity and the material circularity quality for smart textiles. Specific parameters of data of material loss, material recovery potentials, energy to recover the perfect circularity has been addressed. Finally, conclusion. In this lecture, we have demonstrated sustainability in advanced technology, and we have defined current challenges of sustainability in smart textile products. 4 approaches of modular system, conscious design, energy scavenging, and a new value creation in smart textiles has been suggested to achieve sustainability in smart textile products. In the appendix, you will be able to read more supporting information in detail. Thank you.